So, what about crop yields, which was the beginning of this discussion for me? We did some simulations using the same kind of crop models that were used for the projections of effects of greenhouse gas warming. And I don't know to go through all of this, but let me just say what the bottom line is, that carbon dioxide acts as a fertilizer, and plants have little stomata or stomates, so little pores on their leaves. And you can think of plants as trying to optimize. They want to get carbon dioxide in from the atmosphere while losing as little water vapor to the atmosphere. And so they're opening, and you can think of the inside of this pore where the plant brings in the carbon dioxide is wet. And so the more it opens up to let in the carbon dioxide, the more water it loses. And so at high CO2 levels, the stomates don't have to open so widely. And so they can get the CO2 they need with less water loss. And so this allows plants to use water more efficiently. And that's generally called CO2 fertilization. In crop models, people talk about droughts, and here in California, we're worried about droughts from climate change. But it turns out that on a global average basis, it's really heat stress that's most negatively affecting crops. And so these blue lines up here are the effect of CO2 fertilization. And then as this depression from here is the effect of temperature increases. And you can see, especially around the equator, the temperature increases tend to decrease crop yields for some crops. The bottom line is the sort of effects of a solar geoengineering simulation where you remove the adverse effects of the temperature changes and you're just left with the CO2 fertilization. And just sort of in a simpler kind of figure, if we look at this is the projections of projected changes in yields for a few crops. And there's some places where there's not much, there's not much rice being grown at the latitude. So there are some places that will be adversely affected, but overall the indication is that crop yield should increase. I can go deeper into this. And so this idea that this is something, if there are widespread famines as a result of climate change, that this is something people might want to do. I should say that there's two framings for this discussion. That, I'm right now giving you the emergency response framing that, let's think about this and try to understand it in case there's ever an emergency and people would want to deploy it. I should say that there are other people who say, well, look, if there's evidence that this would reduce the amount of climate damage, why do you have to wait to an emergency? Why wouldn't you want to start ramping it in slowly? And I think if you think you'll eventually need it, you would want to ramp it in slowly because you'd want to sort of, if something bad happens that's unanticipated, you'd like to know about that before you turn it on full tilt. But anyway, that could be part of the discussion. So again, just coming back to here, that if this really is causing famines, there's really only one way to prevent this rapidly, and that's by reflecting additional sunlight to space. And one way to do that is to emulate what volcanoes do and put a bunch of fine aerosols in the stratosphere. There's no shortage of risk associated with this. This is sort of kind of obvious. There's international political risk. You could imagine, if let's say China started doing this and then the next year the US turned into a dust bowl or something, whether China was responsible or not, there would be a tendency to blame China for the conditions in the US, and that could generate political tensions in a world where people are nuclear armed and so on. That could be problematic. Anyway, this is something else we could discuss. On the other hand, if the country did just a little bit, we didn't, the United States didn't do anything about Russia or anything substantial about Russia in Ukraine. And so if somebody I don't think we would go to war with Russia because they put a few particles in the stratosphere. But anyway, there's risk of complacency. People are concerned that if people think there's a cheap and easy technical fix, that people won't want to go through the effort of transforming our energy system to one that doesn't use the sky as a waste dump, and that therefore the prospect of climate engineering could end up making things worse. And and the analogy is with flood insurance, that if you make flood insurance either for rivers or for coastal regions, you cause people to build houses where it's going to be flooded. And so if you think that the climate engineering approaches would act as an insurance policy, you could say it's rational to engage in riskier behavior. Chemical risk is, there's concern about, well, if you put particles in the stratosphere, what's that going to do to the ozone layer? The models suggest there would be some damage to ozone, but fairly modest. And again, for the stratospheric aerosols, this marine cloud brightening is different. Ecological risk. One of the things that happened after Mount Pinatubo is because you had these particles, they're scattering sunlight, more light comes down diffusely. And it turns out that after Mount Pinatubo and the year after, forests grew more vigorously. And it's thought that what happened was the light, which normally would come down directly and hit the top leaves in the forest canopy, because a lot of it was scattered and coming down diffusely, penetrated deeper into the forest canopy and helped the understory and the lower branches grow. And so if you did this over time, maybe you'd get more shrubby bushes and so on, and what would that do over time to ecosystems? Management risk, what if the system failed and then you'd unmask the warming that you'd been masking, and you'd get sudden warming, and that has a potential risk. Again, we could discuss all these later. And so, the way I look at it is, there's sort of a balancing question of that there's potential for increasing risk by doing these things, but there's also potential for risk and damage reduction. And at this point, we're at a point where we don't really, know under what circumstances would these approaches really reduce risk, and under what circumstances would risk be increased. And so I would just say that there was recently, I think this was published on February 14th of this year, a report on this topic done by the National Academy, and I was on this panel. And it kind of goes into greater depth into everything I've just been talking about. One of the figures out of this report is this one, which sort of tried to simplify the first figure, but it really points out that the two candidate proposals that were deemed by this panel to be worthy of further investigation was this idea of stratospheric aerosols or brightening of marine clouds. And so with no further ado, I'll turn it over to Armand, so he can discuss brightening of marine clouds. Thank you.